Alice and Bob are playing a game on an array A of size n containing only number 0 and 1. After moving, Alice moves first, uh, with each player alternating turn. Okay, in a player's turn, he or she chose two integer LR such that uh, okay, Alice first. Okay, uh, here it denotes the current length of okay. Then the Savere LR is replaced with a single number 1 minus minimum of the whole stuff. This is okay if all numbers in the Savere are 1, then the Savere eto is removed, uh, and the number 0 is inserted with the Savere was other Savere. Then the Savere, I didn't get it actually. Then the Savere is replaced with a single number 1 to 1 minus minimum of that, that if all that if all the numbers in the array are 1, then the Savere is removed and the number 0 is inserted with the otherwise the Savere is removed and the number 1 is inserted where the Savere was. The game ends when there is exactly one number left in the array. Alice wins if the final number is 0, otherwise Bob wins. Please determine the who wins. Actually, this stuff is feels a little bit confusing. Okay, let's see. Okay, there is only 0 and 1. Then the Savere should replace a single integer. Replace with a single integer 1 minus minimum of that. Okay, actually there's a okay. If all of them are 1, then it's 0. If single one is non-zero, then it's still 1. Okay, they can choose anything. Let's think this one. 1 1 0 1 0 1. Okay, Alice wins. Let's say Alice can take all of them and it becomes 1, so it's a problem for her. 0, so automatically Alice will choose something like she can also choose something like this and make it 1 1, so win for Alice, and win for Alice again 1 1 0. She can choose 1 1, that's 1. Okay, I think I got the answer. If ends with 2 zeros, Bob's win, otherwise Alice. Okay, you are given an array A of length and an integer k. Let f of LR be the value mix. You want to perform the following operation n minus k plus 1 time. Okay, let the current length of the subsequence be a. You need to find an interval LR of length cases that max of a minus k plus 1. Okay. Let the current length of the sub so you need to such that you need to find an interval LR of length k such that max of let me read again. You are given an array on k. Let FLR be the value of mix. You want to perform the following operation n minus k plus 1 time. What it means? If n is 5, let's say k is 3, so 2 plus 1 equal to 3. 1 2 3 4 5. Okay, it's just the remaining portion plus 1. It wants that, I guess. Okay, let the current length of the subsequence be a. You need to find an interval LR of length k such that max of this stuff max of 1 to up to this value f of that part equal to f of LR. In other words, you need to select a window of size k such that among all windows of size k, the window you select has the maximum mix. If multiple error exists, you may select any. Then you must select an interval I such that LR and delete AI from A. That is your sequence will be something like that. Okay, for example, in the array 1 2 0 1 3 with k equal to 3, two possible LR pair are 1 3 2 4 1 3 2 4. Since there exists mix 3, what is the maximum among all windows size 3? Therefore you can remove any of their instance in indices 1 2 3 4 in your next move. After n minus k plus 1 operation, you will have a sequence of length k minus 1. Objective is to maximize the mix of the remaining element. Please output the maximum mix possible. I'm a little bit confused. In the third test case, let's see this one. In the third test case, we can perform the following operation. Select I equal to 1, j equal to 3. This allows because 0 1 2 1 0. Okay, select I equal to 1, j equal to 3, equal to I guess 1 and 3. Let's assume 1 index. This is allowed because the mix of all windows of size 3 is 303. That makes sense. Maximum is 3, and the window 1 2 has 1 3 has the mix of 3. Window 1 3, where's window 1 3? Okay, 1 3. Okay, mix of 3, which is the largest. Then remove a2, the sequence becomes 0 2 1 1 0. Okay, I can remove this one, they are saying. Okay, select I equal to 2, j equal to 4, then remove a2, then again remove a2, means this one. Okay, I got the point. If k equal to is 3, so 5 minus 3 plus 1, that's 3. I have to remove at least 3 element, I guess. Yeah. Okay, n is 2e5, n is 2e5, 0 1 2 4 0 3 1, 0 1 2 4 0 3 1. Here's k is 5. If k is 5, so n is 3. I have to remove at least 3 elements. Okay, maximum mix of k length, 5 length. 1 2 3 4 5. I have to remove at least 3 values. 0 1 2 0 0 4. Actually this is the valid one. 0 1 2 3 4. Mix is max 5, so I have to remove from here. At first I have to identify all the different what's the value of k? K is 25, n is 0 to n, sorry, a is 0 to n. Okay, I have to select a segment with 5 value. Zero at 1, 1 at 2, 2 at 3, 3 at 6. It makes a change. 3 at 6. I'm just removing values, so 1. Third test gives 2. The first thing is if I take a segment of 5 values, 1 2 3 4 5, and if that has the max mix, no matter what, otherwise if there are multiple this kind of segment, I have to remove the max 1, max 1, max 1, max 1. Can I do something like that? Let's say I have one segment with 0 1 2 3, another segment with 0 1 2 3, so I've removed 3. Then I'll go to this segment, remove 3. I'll go to this segment, remove 2. Okay, so somehow if I can divide all the segments from the max value, how can I do that? Sorry, this is the max value. As user hacker search is able. 4. If there is extra values in this segment, max is 4, max 4, but there is extra values, something like 1 2 3 4 5. let's say my mix is 4, sorry, max is 4, mix minus 1 is 4, so I can easily remove one value no matter what. No, I can't. I have to see the LR. One, two, three, four, 5. I'm selecting this one, removing any. That's mean 4. Removing 4. Then I'm selecting again this one, removing 3. Actually, take this one, remove 0. Then take if I remove 0, 1, 2, 3, 4, 5, then if I take this one, I can't take this one. 1, 2, 3, 4, 5. I have to take this one. So 0, 1, 2, 3, 4. I have to remove 4. So the value is 4. Yeah, 4. Value is 4. Let's say I've taken a segment which has all the values for max mix. Okay, and I see some duplicates. 1 duplicate, 2 duplicate, number of duplicate 1, 2, 2 duplicate, not 3. Is it that simple? I don't think. 4 minus 2 plus 1, that's 3 again. 0, 2, 1, 3. No duplicates, so 1, 2, 3. Is it that simple? I have a doubt. Most probably I will get WA, but let's try because I have no other ideas. Let's do a map. I'm doing map maybe as, let's do any. I'll just short it 2 times. So a 118. it's not k actually. Zero, zero. K is 3, so my value is let me see, count oh, that should be enough. Count is 0. Count should be, oh, I haven't updated previous. It's still showing as 0. Previous equal to arrow phi. If previous equal to arrow phi minus 1 equal to 118, and previous equal to arrow phi, previous equal to, am I doing something wrong? And k arrow phi up to and arrow phi. If pre equal to arrow phi, no matter what, it should update. Look at that, was a mistake. Two, one. I'm not sure it will gonna pass or not, but let's try. Because I don't have any idea. 2000 submissions, so it might. Wrong. First I have to select a segment with the max mix of size k. I have to remove n minus k plus 1. I have to remove n minus k plus 1 values. So it's saying I have to let's say 1 2 3 4 5 1 2 3 4 5 values, and I have to remove one more value than the whole remaining section. So no matter what, I have to remove one value from here, then it will gonna shrink, it will gonna shrink, it will gonna increase, and it will gonna go for here. Should I go to problem C or something? 3000. Okay. A wire has broken out. You, as the country's top general, must stutter where to place your troops. There are an bases in the line where the kth of which being the home base for your army. Okay, kth of which, okay, initially there is only a single soldier at base K. Each day the following happens. uh, base base K, the kth of which being the home base for your soldier. Okay, the following happens. You give out an order by choosing a base I and any number of soldier inside that base, which is allowed to be 0 or all soldier in the base currently. They tell all soldier your order to either move to base I minus 1 or base I plus 1. All soldier must move in the same direction and no soldier is allowed to move to the left of base 1 or the right of base. Okay, then a new soldier moves on to base K anew. The soldier cannot be ordered by that day's commands. Okay, how however time is tight and there are only m days until the enemy attacks, a base is called fortified if at least one soldier reside in it. Your job is to find the maximum number of for fortified base you can have by the end of the mth day. Okay, you give out an order by choosing a base I and any number of soldier inside the base. Then tell all soldier your order to either move to base I minus 1 or I plus 1. All soldier must move in the same direction and okay. NMK denotes the number of base, the number of day and days you have to forfeit the days and the index of the home base. Okay, it is quadrant that the sum of n. Okay, in the second test case answer is 3. In the second test case, or I should say the third one. In the second test case, here is a one way to fortify 3 base. One of the on the first day, order 0 soldier in base 3 moves to base 2. At the end of the day, a new soldier moves to base 2. Okay, base 2 soldier base you give out an order by choosing and base I and any number of soldier inside the base any number. Okay, then tell all the soldier you ordered either move to base I minus 1 or I plus 1. All soldier must move in the same direction and no soldier is allowed to move to the left. Okay, then a new soldier moves into base K. I think I got the point. 3 base. Okay, my main base is 2. I have 3 days. At the first day, in the first day, order 0 soldier In the first day, order 0, soldier in base 3 moves to base 2. In the first day, order 0 in base 3. Okay, you are given an order by changing which case being the home base of the army. Initially there is only one single soldier at base E. Okay, I'm assuming here is one soldier. At the first day I ordered to move somewhere. Let's say I'm ordering him here. So that's 0. In the second day I'm ordering one a pair here. I'm ordering to one shift, so it will go 1 1 0. In the third day first day order soldier to move 3. Okay, at the end of the day a new soldier moves to 2. Okay, on the second day order 1, soldier in base 2 moves to base 1. At the end of the okay, I guess those are independent, I guess. Okay, day 1 move here, 1 appears here, day 2 move here, and 1 appears here. That's that simple. So value is M is 1E9, day is too long. Okay, which allow to move 0 all soldier in that base currently. You give out an order by choosing a base I and any number of soldier inside the base. Okay, got the point. N can be 10 to the 5, M can be 1E9, 10 to the 5 1E9, and K can be what's the K? Okay, is the base. Okay, K can be 1E5 also. So is it a simple simulation problem? Maximum direction. Oh, I can order 1. Okay, let's put 1 value here. Let's 0. And second day, first day to appear here. I can order just in here. Day 1, day 2, makes sense. Okay, so it moves to there and 1 will appear here again. Next day I can order it here, so it's empties out. It will move, 1 will move here and y remains here. I can say here is infinite values. I don't have to generate anything. I think it's just a simulation problem. Infinite value. I can make it +1. Oh no, not infinite value. day 1, that, day 2, that, day 3, one option, I move it here, day 4, I move that one there, and here is 1 1. Day 5, I move that one there, and there is 1 1. Day 6, I can move 1 1, and it's 1 1 1. M is 1 9. It's a little bit like infinite. It appears more value than I need. No matter what, the spot will not be empty. Day 1, day 2, day 3, day 4. Let's move both of them. 1 1 1, new value appears, and there's 1. Day 4, day 5, 1 1. It's really confusing. Length is such that max for example, in the array 1 3 0 1 3 0, when k equal to 3, the two positive LR 1 3 and 2 4, since each has mixed 3, which is the maximum among all windows of size 3. Therefore you can remove any one of the index 1 3 3 4 in your next move. After n minus k plus 1 operation, you have to have a sequence of length k minus 1, length k minus 1. Okay, I'll have a length of k minus 1. So if I have multiple k's, no matter what, all of them are destroyed. All of them are destroyed. So I think my solution should have worked. Let's make an example. Let's say I have 0 1 1 2 3 0 0. Let's say case 5 1 2 3 4 5 6 7, case 5, so I have to remove 3 values. So max segment is 0 1 2 3. This stuff, I can choose this stuff. Oh, sorry, this stuff. So I'm removing 1 0. So 0 1 1 2 3 0. Then I have to remove, choose this one. Let's remove 1 0 1 2 3 0. Let's choose this one and remove this one. So 0 1, answer is 4. So 1 7 5 0 1 1 2 3 0 0. It gave me 4. Four, 1, what k can be 2, okay. So give me answer 0. Makes sense. To remove 2 value, 0 3. So 0 to 3. I can remove 3. Then this one, 3 is already gone. I can remove 2. So 0 1 2 is my mix. That's correct. If the value 0 0 0 0, is there any 0 0 0 0 3 3 3? Let's say k is equal to let's shorten it out. K is equal to 1 2. K is equal to 3 4 5. So let's remove 3 values. Okay, then k is 5, k is 3, k is 3, 5 minus 3, 2 plus 1, that's 3. Okay, k is 3. So there's the best option. I remove 0. Let's randomize more. Let's put 1 here, 0, 2. Best option is this one. I'll remove 1, no problem. Then this is gone. Then best option is 0 1 2, this one. I'll remove 2 again, so 0 1 2. Then best option, the whole stuff, I'll remove 2, so 0 1. I think the logic looks good, but got a was, so 2 0 1 1 2. Answer is 2. Makes sense. Your objective maximize the mix of the remaining element. Please output the maximum mix possible. Yeah, that's correct. Code is equal to n minus k plus 1. If there is a duplicate, if previous equal to error of I, then error of I, then error of I minus 1 equal to 118, then count plus plus the previous equal to update, and sort again up to n. If error of I equal to mix plus plus, if count, if we get greater than equal to, that's still the same. If those are equal, mix minus equal to 0, so it doesn't change. Mix can never be a negative number, so I don't have to think about that. I don't see any problem. Okay, if the values are disconnected, there is also a chance. Else not this one. If those are equal, mix plus plus, else count plus plus. I think this is a chance. Yeah, that was my mistake. 5 3 gives me 3, other right gives me 1. Okay, if that's disconnected, 0 0 1 2 4 0 3 1. Else if error of I not equal to 118, then it should work. I think it should now work. It was a simple mistake. 3 2 0 1 100 100 2 0 1. Okay, so I have to remove 3 value 1 2 and this one, that's 2. Okay, let's try again. I think it should pass now. It will pass, I guess. Pass. Okay, the simulation one. it felt little bit harder. Only 1,000 people have solved it. So the main stuff is I have some point and somewhere I'm getting +1. And I can update value at once. If I have 1 here, number of day, let's have 3 values here. Okay, I have number of days more than 3. Let's say 5. Three days, extra days 2. Okay, extra days 2, so I can wait 2 days here. Day 1, day 2. At the 3rd day, I will move 1 here. 3. At the 4th day, I'll move 1 1. At the 5th day, I'll move 1. That should work. If I have less days, what can I do? At day 1, let's say I have 4 days. At day 1, I'll put it here. At day 2, I should put value here. I have 4 days. I have 3 values here. So 1 extra day. 1 extra day. So no matter what, I need total 3 values. I need total number of values minus 1 days extra. So 1 second day, at second day, let's say third day is my last day, so I'll move. If I think optimally, how many I can fill up without any kind of loss? I'm thinking optimal is always putting all value in here. Let's say I have 3 values here, so obviously I need 3 minus 1, 2 days, 2 days to fill up them, and I want total 3 values in here, so 3 value will take 3 days. Okay, let's think about this one. I have 4 position, 4, my base is at 3, this one, and I have 3 days. Okay, so I have 2 days here, so I'll try to do it in this direction first. So number of extra days 1, and number of total value I want is 2, so total it will take total 3 days to fill up the whole stuff. To fill up the whole stuff. Okay, so 1, 2, 3. Those are 3 position. Let's say I do that. Okay, day 1, 1, 1. Day 2, I can do that 1. Day 3, I have to wait. So obvious answer is putting the values in day 2 here, if I want to fill up 2 values, I need 2 plus n minus 1 days. If I want to fill up 1 value, I need 1 plus 0 days. Yeah, I have some days, so I have the day. Okay, I have the day, so from what's the minimum value? N comma m is the day, comma k is what was the key? Oh, base. Okay. I'm thinking, should I do a binary search kind of stuff? I have some amount of values. How many can be done in those days? That's the main goal. A equal to is base, let's name it B. No, base, let's stay base. So 1 2 3 4 equal to is base minus 1. Now B equal to is 3. 1 2 3 4 5 6. Where's the base is here? So 6 minus 4 and minus base. If B greater than is swap A, B. Okay, so let's do a binary search. Start equal to 0 and equal to A. Less than equal to E. Max equal to 0. Meet plus meet minus 1. I think there is some better way without doing binary search, but I cannot think anything at this moment. If that's less than equal to D, max equal to meet and start equal to meet plus 1 else start equal to and equal to meet minus 1. Okay, so T minus equal to max plus max minus 1. Let's put a max of 0 LL. It will be negative, so max plus max minus 1. It's just same as 2x minus 1. Okay, I've done it, so done it. Out day space max plus 1. Just seeing the values. 0 2 2 2 1 2 2. Okay, max is huge. Why that's that much? 99999. Why the max is this large? S plus E minus S divided by 2. Yes, right. Mid plus mid minus 1. Day is obviously less. And day base, this is right. Start and then start and it's 99999, 99999. Day minus equal. Oh, those are the days. My mistake. Okay. Then I'll do another binary search on the remaining portion. Let's make it B. Start something something. Mid plus something 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 something. Okay. This is the store max 2. Max 2. Max 2. Max 2. That's max 2. Okay. Max 2 plus 1. That should be the answer. Okay, didn't pass. 2 3 3 2 3 5. Okay, so the last. See out MX. Okay, it had 7 days. 1 2 3 4 5 6 7, and phone number 1 2 3 4. Phone number is the 1, so 3 3. Okay, max is 2. Max is 2. 2 is 2 plus 1 3, and for 3 it needs 3 plus 2 5. Yeah, 3 is possible. So okay, 3 max was printed before. Okay, 3. Yeah, 5. So remaining day should be 5 6 7 6 7 2 days. Okay, remaining days is 2, so there's 3, and in the next condition, that's 1 3 4. It can have 3 values in 5 days. Day 1, 3 values, 1 2 3. Okay, day 1, day 2, day 3, day 4, day 5. Like a 5 day, and remaining 2 day. Remaining 2 day, day 1, day 2, it's on here, three, 4, 5. Can I do better? Let's say fill up 2 values. Day 1, 1, day 2, day 2, then day 3, day 4, day 1, day 2, day 3, day 4, day 5, 1 1, day 6, day 7, 1 2 3 4 5. Day A and B are the same. Three, 1, 4, 3 takes. If I do 2 2, then total 5. It's saying I'm doing 3 and 2. 3 4 5 6 2. Yeah, if I have 1 and to fill up day 1, day 2, day 3, day 4, day 5, day 1, day 1, day 2, day 3, day 4, day 5, day 6, day 7. I shouldn't do it this way. Day 1, day 2, day 3, day 3, day 4, day 5, day 6, day 7. I have only 7 days. I'm not seeing. It has 6 answer. 774 in the 6th case. One, two, three, four, five, six, 7. Let's read the question again. Am I missing something? You are given out an order by choosing a base I and any number of soldiers inside the base. Then tell all soldiers you order to either move to base I-1 or base I+1. All soldiers must move in the same direction, and so no soldier. Okay. Then a new soldier move into base K. This soldier cannot be ordered by that day command. However, time is tight. Okay, I've understood the question properly. Okay, day 0, day, let's say day 1. Let's put the value here. New value appears. Day 2, new value appears. Day 3, day 4, day 5, day 5, day 6, day 7, day 7, one, two, three, four, 5 machine. Is there any clarification for C? General announcement as 3000, so I should be able to solve it. (774) NMK. M is the day, K is the number of the current base, and it's a total base. 774. Answer is 6. Seven seven four. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. That's my base. So day 1, let's move it here. Day 2, let's move him also here. Day 3, Let's move both of them here. Day 4, let's move 1 1. Day 5, let's move them there. Day 5, let's move them there. So day 5, then 6, 7. That was my mistake. Let's say I have 1 2 3 4 5 6. Okay, it will take, if I make, how many days have I wasted? Let's see. There is 3 values. Okay, there is also 3 values. At day 1, there's 1. At day 2, there's 2. At day 3, I'll move them there. Day 3. At day 4, I'll move them there. So it took 4 days. Three will took. If I waited 3 days, I want to accumulate 3 values here. Okay, day 1, day 2, day 3, 3. Then day 4, it gets 2. Day 5, it gets 3, it gets 1. Day 6, day 7, it should be something like that. So it took actually 3 days. Then after max minus 1 day, actually max value is, yeah, max values, day, I can add some days actually. I've saved actually how many days? Let's say I've accumulated max values. have accumulated max values. Depth plus equal to max minus 1, I guess. Two, three, three. Okay, the start position have 3 values, max values. Okay, so for long loop I equal to 0, equal to 0 to p I plus plus let's say I have 3 values here. Okay, I have 3 values. Positions are 1, 2, 3, 4, 5 positions. I have 5 positions. I need 2 more value, so it will cost 2 day. It will cost 2 extra day. Three, 4, 5, 2 days. Three at the 4th day. 4. Okay, it will cost 2 more day. Then 1, 2, 3, 4, 5. Binary search is valid. So actually this long current equal to max start equal to 0 and equal to if extra tray, if meet plus extra equal to minimum of extra is if there is less values if extra equal to 0 if CR and current less than EX, then EX equal to meet minus CR and current plus extra. If meet plus extra less than equal to day, mx2 equal to meet start equal to meet plus 1 else and equal to meet minus 1 mx2 equal to 0 plus mx2. Looks like it should work. I hope it will work. Please don't give. Wrong. It cost too much. Let's say on a, it's definitely binary search kind of stuff for sure. 6, 7, 8. Let's say I want to occupy at least 5 values. Okay, 1, 2, 3, 3, 4, 5. Okay, at least extra 5 values. So in this direction I have to, in any direction I have to take 3. 3. If I take 3, it will gonna be something like, oh, it will take 3 days for fill up. 3 and 4, 5. 2 more days. So it will occupy 3 values. So it will take 5 plus, for this 3 it will get 2. Okay. Best option is divide the whole segment. Divide the whole segment. Val divided with 2. In A direction I'll try to take, if b greater than equal to meet, then it's okay. Let's do it often. if start if count 1 greater than equal to greater than count 2, count 2 greater than equal to count 1, and count 1 plus plus, else count 2 plus plus and val minus minus. Okay. So long day. Day equal to first is count 1. Count 1 plus count 1 plus 1 minus 1. Day plus equal to number of count if day less than equal to day less than count, less than count 2, then day plus equal to not day, count 1, then count plus equal to is, that's not possible. Count 1 always will be greater. Yeah. Then just day plus equal to count 2. Return day long. Start equal to 0, end equal to n minus 1. Well, start less than equal to n. If okay meet less than equal to day, I also need k base. Oh, I have another problem. If count 1 greater than count 2, then count 2 plus plus, otherwise always count 1 plus plus and count 2 less than b. I think that's the correct one. If count 1 greater or count 2 less than, yeah, that makes sense. If day answer equal to meet, start equal to meet plus 1, and equal to meet minus 1, out. Answer +1. Standing looks really sad, at least for me. Okay, it will pass. I have 1 more hour, so if I can solve problem D, I think that will be good enough for me. Easy version. Yeah. Oh, come up to position 3000. Okay, you are given a rooted tree consists of n vertices number from 1 to n. After a long time, tree question, where the root has index 1 and each vertex is initially white. Define di as the distance from the root to the ith vertex. Root to the ith vertex, you can perform the following operation any number of times. Select a subset S of which vertex such that two nodes in S are connected by an edge or have the same distance to node 1. More formally, S should satisfy for all x, y. And there are no edge between x, y. Select a subset S of for which vertex such that no two nodes in S are connected by an edge or have the same distance. Okay. Color the vertex in black. Your job is to find the minimum number of operations required to color the full tree black. Okay. Answer is 5. Let's take the first. Okay. Is there any distance? Index 1 initially which day has defined d as the distance from what's the distance? Initial define d as the you can perform. I think every value has one distance something, so obviously it will need 1 2 3 4 5. It's obvious, super obvious. Again another one. Root is 1, so I can select 1 2 3. Oh, I can't select. I can select different level actually. This value, and so I can take any two. No, I can't take any two. This is also a bad example, I guess. 4. Answer is 4. Number of value 1 2 3 5. Here's 4. I can take connected values, so I can take this. The distance is 1 2. Let me see the question. UV and you are given a one for initial hole defined initially wide, defined d as the distance from the root to the ith vertex. You can perform the following operation. Minimum, yeah. Let's see in the test case 2. In the second test case, we can show that at least a number of over 4. One way to do the color is note 1 and 3 in the same operation. 1 and 3, yeah, makes sense. 1 and 3 at the same operation, and those and different. Yeah, makes sense. I have to think. Let's say I have a graph. Obviously, in single operation, let's put them in some value. 0, 1, 1, 2, 2, 3, 2, 2, 3, 3, 3. Okay, I can select this one at once, this one at once, in just 2 operation. Oh no, I can't take all of them. I was wrong. I can take this one, any one of them, sorry, not them, this one, any one of them, one operation. This one, this one, any one of them. I can take any of them. Okay, this one and any. E5, one, 2, 4, 3. Okay, so 1 can minus 1, so it 1. This can minus. Okay, I think got it. Let's verify one example. Let's verify this one. Its answer is 4. One, 5, 4, 7, 6, 3, 10, 9, 8, 2. Okay. 0, 1, 1, 1, 2, 2, 3, 3, 4, 4. Okay, so 0, 3, 2, again 2, then again 2. So 0 is 1. So at first 1 operation, I'll make it 2. Then it will take 2 operation. It's gone. It would make 2 operation. So total 5 operation, I guess. But answer is, I think, 4. Yeah, answer is 4. Did I did something wrong? Level 1, that's 3 values. Level 2 is 1, 2 value. Level 3 is 2 value. Yeah, so 1, 3, 1, 3, 2. Oh, I can take okay, 1, 3, 2, 2, 2. 1, 3, 2, 2, 2. Those are level by level. If there are multiple values, I can take any of them. 1, 1, 1, 1, 1, I guess. 1. I cannot take this. I can take this one. Cannot take this one for now. Take this one. Let's take this one. Then cannot take any of them. One. Drag. I can take one from here, one from here, one from here. Okay, so 3 values are gone. You know, one operation I can take 1, so 0, 3, 1, 2, 1. In second operation I can take 1 here, 1 here, and nothing else. So in second operation 0, 2, 1, 1, 1. In third operation I'll take 1, 1. So 0, 2, 0, 0, 1. Fourth operation I can easily take 1, 1, but 1 still remains. 1, 3, 2, 2, 2. 1, 3, 2, 2, 2. Yeah. We can take this 3, and this both 3 is connected. So I can take any of them. Yeah, I can take any of them. 3, 4. One, 3, 2, 2, 2. Okay. 1 is responsible for next all 3s. Then 1 is responsible for 2 2s. One of them is responsible for 2 2s. 2, 0, 0. 1 2 is responsible for both 2. 1 is responsible for both 2. Then another one is responsible for both, and it has 0, 0. Okay. So take 1, take 1 again, take 1 again, take 1 again. Okay, so 0, 0, 3, 1, 1, 1. Next operation, let's take 3, 1, so 2, 2 1 0 1. Next operation, let's take 1, so it will gonna be 1, it will still 1 0. I can take this one 0, so 1 2 1 2 3 operation. In fourth operation, wow, still getting positive delta. That's should I traverse the graph and do something? If I go from here 1, I'm allowed to take I'm not allowed to take 7, so skipping 7, taking 3, main problem is connected. I can't take connected. If I take 1, I can take this one, I can take, can't take this one, can take this one, can take this one. Let's mark the distance again. 0 1 1 1 2 2 3 3 4 4. Okay, let's color this one. I can take any connected, I cannot take any connected parts, so let's take this one. So I cannot take any 2, let's take this one 3. I cannot take 3, let's take F4. Okay, so it's operation 1. Let's go operation 2. Let's take any of them 5. Now I can take 3 because those are not connected. 5 3 and 2. Operation 2 done. Operation 3, I can take this one, this one. Now operation 4 is only 1 remaining, so that's obvious. So 4 operation easily. So how can I do it in a elegant way? I cannot take any child from this level. If I think in this way, once child is 5 7 4. Okay, then 5 child is null, 4th child is null, then 7th child is 3, okay. Obviously if I take 1, I cannot take any of its child, so I have to ignore them. Then I'll go to the next value. I'll go to the next value. If I do a Euler tour kind of stuff, I can take one number of child is 3, then 5 number of child is 0, then 4 number of child is 0, 7 number of child is 2, so 3 2 number of child, what's the number? I have no idea what I've written here. Let's guess, let's say it's 6, then 3 has 1 child, then 9 has 2 child, 8 0 2 0, 3 had 2 child actually. Mm. 55 minutes. 1 7 3. If I take 1, I have to skip next 3 value. Okay, then let's say I've taken 3. If I take next level 3, let's say level 0 has 1, level 1 has 5 7 4, level 2 has 6 3 10, level 3 has 6 and 3 not 10, level 3 has 9 10, level 4 is 8 2. Okay, if I take 1, I cannot take anything because all 3 values are occupied, and also all 3 values are occupied. 1, some kind of 9 is connected to both, so I cannot take anything. 10 isn't connected, so I can take both, but I have to take only one, so I'll take this one. So it has 2 values. Okay, then let's take 1. I cannot take anything, so skip this one. Then from here, let's take a random one. Let's take 6. If I take 6, I can take any of 9. If I take 9, I cannot take anything, so those are gone. So this dimension is fully ignored. The next one, let's say I've taken 5. If I taken 5, I can take anything. Then if I have taken 3, I cannot take 9, so I'll take 10. Obvious. Okay, it makes sense. There is an optimal way actually. It doesn't make sense, but for 6 I have to take 9. I cannot take 10. Oh no, I cannot take 10. Okay, for 3 3 is connected to 10, so I cannot take 10, so it stays there. Then for 8 2 I can take any of them. Let's say I've taken this one. 2 operation. Okay, 2 operation done. In third operation, let's take 7, then for 10, fourth operation 4. Yeah, I think that's the way. Just and 1 2 3 4. Misclicking. Okay, okay, I haven't thought how will I uh, do this optimally. I can create a linked list easily to just go forward, and if anything gets fully emptied, I'll just remove that easily. But how will I know the value is not connected to something? Which value is not connected to something in fast? Should I change the child once child is 1 something, 2's child is 2 something, 1 something, if those are pairs? So I'll just do upper bound kind of stuff. Like to have something not equal to that value. So let's say I have x before every values. Okay, 1 3 1 4 1 5 something, and there is 2 3 2 5 2 something, and 3 something something something. So let's say my value is 3, so I'll say front or back. My value can be from the beginning or from the ending, or any of them. Yeah. Level. level equal to I need the parents and also level. I think it will give me all the information I need. Void, okay. DFS 1,0,0. Okay, so I need some not vectors, multi-set to. I can also use set because those are pairs, those are unique values. Okay. Set also I should mx equal to 0, mx equal to max of lv comma mx, mx equal to 0 before I do a call. Also I should clear up g of I dot, yeah, set okay, so okay, so I'll first put all the values in the vector. After that I'll try to put them in a linked list kind of stuff. How much time I have? 42 minutes. First value is the parents, okay. VP push back a comma Hi. Yeah, that's my goal. If ppi dot size to create a linked list. I've never created I think I should copy it from the triad. Why it's showing error? Yeah. Okay, so if it has a size, I'll do something like I'll put up every value in the current. Why can't I do pushback? Is it insert? Yeah, insert. So also I need to create then I need to create a new value, I guess. Current next equal to new and current equal to next. Yeah, that's that. also I do have to clear them. Node not need return. If I don't need all of them. If not next, it will go to the clear. Okay, it's a recursive function. I hope it will work. So that's that. Now I have to run one by one. While current not equal to null bit here, start current equal to start. Previous equal to minus 100. I'll take the front long. Let's put an auto a equal to current st dot begin ouch, I've forgotten some stuff. I haven't cleared the node, so that's that one. So let's put also clear function. Try. So it accessing nice begin. Last value is a garbage value. Why? I think how can I do it safely? In C, most efficient max value is max value S begin. Mean value S. Okay. It works. It works. No. Minute 0101. Oh, makes sense. Makes sense. Makes sense. Makes sense. Then just go to the next current equal to current equal to current next sigpass. Something is wrong. Current not equal to null PTR. Current next. If we have a size count plus count only one. Just watch. Level 0, level 1. Just printed 0, 1. Only printed 0, 1. Something is definitely wrong. For auto AB, out A space B 0 0 0 1. Zero one one two, yeah, all of them are right. Push back in vector pair. B is the level. Okay, P is the level. So then from every single vector up to max, what's the max? Max is 1 equal to max. No, it should work. Let's see this. Something's still wrong. Say out v dot fast one one 2 3 4 5. Zero one, yeah, makes sense. 0 2 0 3 0 4 0 5, yeah, makes sense. So values are also okay. I'm assuming those are getting inserted properly. So current equal to that. Zero and 0 1 makes sense. Current not equal to something. It just goes into infinity. Next equal to null pit here. Current equal to current next. Pointer current equal to start. Start is okay. In here I'm doing current next, new node, then current equal to next. That's that. Then current null, A and B, printing A, B, current equal to current next. I think printing is the main problem. No, not the printing. Current, okay, let's count equal to 0, count plus and count less than 2. 01 02 05. My main problem is it's just going out of bound. While current null bit here, I have put in that, but null bit here, yeah. Current next equal to null bit here. Current next. Okay. Plus, okay. Null bit here isn't working somehow. So if that max, I'll do something. Also count should be here. Less than equal to. That makes sense. If a dot second, also I need previous equal to minus 100. If a dot second not equal to previous cr and current as t dot is a, else if b dot second, then remove b. if here current st dot size equal to 0, if that's empty, previous pointer also I need the previous pointer. PP, okay. Else if I'll remove it if the size is 0. I'll then if that happens, start previous. PP next equal to current next, and current next equal to null ptr আর হচ্ছে clear. current আর হচ্ছে current equal to pp. If I remove start, what will happen? If I remove start, it will, yeah, normal. mx minus still C plus. Remove also previous. Previous equal to a dot fast. Previous equal to p dot fast. I'm getting really confused. Simple stuff.